Hi everyone, this is our intro lecture video for section 2.1, which involves the distance and the midpoint formulas. In this chapter, we are going to be dealing with the graphing of lines. This very first section introduces you to the rectangular coordinate system and the distance and midpoint formulas. So what exactly is the rectangular coordinate system? The rectangular coordinate system is a coordinate system established by the intersection of two lines, a horizontal line and a vertical line. The horizontal line is called the x-axis. The vertical line is called the y-axis. Where these two lines intersect is called the origin. So the origin is the intersection of the x and y axes. It has coordinates 0, 0. What exactly are coordinates? Every point P that is in the xy plane has an x coordinate and a y coordinate. So every single point that you have in the xy plane, it has a horizontal component and a vertical component. The horizontal component, that's the x coordinate, it is listed first in a point, and the vertical component, that is the y coordinate, is listed second. In the xy plane, there are 4 quadrants, and each one of those quadrants has its own sign rules. For points that are in quadrant 1, the x and the y are positive. For points that are in quadrant 2, the x is negative, the y is positive. For points that are in quadrant 3, the x is negative and the y is negative. For points that are in quadrant 4, the x is positive and the y is negative. So in this section, you are introduced to the distance formula. What exactly is the distance formula? So let's suppose you had 2 points. For sake of example, I just drew these 2 points in quadrant 1, okay? So point 1 has coordinates x1, y1. Point 2 has coordinates x2, y2. How do you find this distance between the 2 points? You see this line that I drew here in blue? How do I find that, I shouldn't say horizontal. How do you find that distance between the 2 points? The distance between those 2 points is given by the following formula. It is equal to the square root of the sums of the squares of the differences in the x's and the y's. Let's take a look at an example where this formula is used. So in this example, you need to plot each point and find the distance between the 2 points. So the first point, P1, has coordinates 3, negative 4. Remember that the first coordinate that's listed in a point, that's the x coordinate. The second coordinate is the y. So for P1, you have x is 3. And y is negative 4. So my increments here in this example, my increments are going up by 1s, okay? So this is that first point, P1, with coordinates 3, negative 4. The second point has coordinates 5, 4. So 1, 2, 3, 4. 5, 2, 3, 4. So here is that second point, which I'll denote by P2. Scrolling back up to the question, this question asked me to plot each point, which I did, and to find the distance between the 2 points. Okay. So I need to find this distance between the 2 points. So I'm not finding the line that connects these 2 points. I'm finding the distance between the 2 points, okay? We're going to get into lines in a later section in tomorrow's lecture. So how do I find that length in blue? So that length in blue, we can calculate this using the distance formula. This is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. I have my first and second point listed here, and now I'm just going to plug in those respective x and y coordinates into this formula. So x2, that would be 5 minus x1, which is 3, y2, which is positive 4, minus y1, which is negative 4. You must include the signs of those coordinates when you plug them into this formula. Now bear in mind, P1 and P2 were given to me here, like in that order. If they just provide you with 2 points, it doesn't matter which one you call point 1 and which one you call point 2. The result when you use this formula will still be the same. And I will illustrate this tomorrow in our lecture. So let me simplify this thing here. Let's see what we have. 5 minus 3 is 2. 4 minus negative 4 is going to be positive 8. Two squared is 4, and 8 squared is 64. So this is going to be the square root of 68. Now let's see if we can simplify this further. So 68 is the same thing as the square root of 4 multiplied by 17. The square root of a product is a product of square roots. 4 is a perfect square, so this will simplify to 2 square root of 17. And that takes care of this problem. Alrighty, everyone. I will see you tomorrow.